Hello, ladies and gentlemen, and welcome to our project, Cardiac VR. We are Group 15. Our sponsors are Melissa Cohen from the UCF College of Medicine, as well as Dr. Gerber. I'm Ian Markwich. I'm the project manager in Unity Dev.
I'm Fatih Alfanmashek. I'm the Unity dev and also involved in prototype testing.
I'm Xavier Hutter. I took the lead on database integration while also working on general Unity development.
I'm Kelvin Florenciani. I was the Unity dev focused on the environment design.
I'm Naim Shako. I'm a Unity dev focused on UI UX, and I also helped with the database.
I'm David Winfield. I was a Unity dev in charge of VR controls and tutorials.
All right, so project goals, we wanted to make a port of the existing cARdiac AR app into a VR, specifically with a Quest 2 headset, and to be used as a study tool for M1 and M2 students to study cardiology. The reasons we went into this was because AR is cost prohibitive at $1,000 per headset usually, and VR is more intuitive for controlling.
Now for our project, we wanted to help make the cARdiac application more accessible for UCF medical students and professors, which would contribute to bringing another dimension to learning through the use of virtual reality. cARdiac VR would also help provide an alternative to traditional learning methods, while also giving access to a situation that might be hard to access in real life.
So for this application, we defined our minimum viable product as follows. We have a interactable flashcard that can keep track of duration and confidence levels. We have case study questions that prompt students from a selection of choices and then also inform them about whether they're right or wrong. We have an interactable heart model, which is the main purpose of the application, that shows different heart rhythms as well as anatomy, electrical and blood flow, as well as EKGs corresponding to those rhythms. We've also included a tutorial for VR movements, as well as a database to store performance metrics regarding those case study questions, as well as flashcards.
Some of our overall design decisions included choosing Unity as our engine due to how documented it is and having pre-built VR libraries, making our entire application 3D over 2D, using Plastic SCM as our source control due to it being purpose-built for Unity, and having a relational MySQL database as our choice.
We divided up the lead roles for each task within our projects as follows.
All right, so room layout, we went ahead and implemented the room this way, have a 3D layout. Again, we did a 3D environment. We decided to make it mirrored because we felt that this would help familiarity between previous users, and it would help to create a hospital feeling environment. Some stuff we had to overcome was that it's much more difficult to make a 3D environment, and you have to account for more factors such as lighting and space.
For implementing VR, we decided to use the Unity XR system, which is a toolkit that provides a lot of basic functionality for getting a user into VR. It gives you a headset, a left controller, a right controller, as well as the basic functionality for each of those different objects. We also created a settings menu that would let the user change various different comfort settings based on their prior experience with VR. We also created individual tutorials to explain how to interact with some of the major objects that you can find in the environment, including our flashcards, heart interactions, and cases. Initially, we struggled with implementing controls beyond the defaults that were provided by the Unity XR system. So to fix that, we needed to implement entirely new controls to get some of those different components to work.
So for heart interactions, the first thing we changed was the animation controller. We utilized the any state to go to the 4 different heart modes, as well as an idle state of animation. We also added grabbable model. Rather than just the static, scalable, or rotating, you could also pick it up for a better view. We added 3D anatomy labels, which could have detailed view in the anatomy window if clicked on, as well as being able to track the face of the user, be able to read it wherever their head is oriented. Some struggles overcome when adding all these UI elements and porting over the other ones. It was hard to make them user-friendly at first, but when splitting into M1 and M2, we found something that worked. Orientation mechanics with the grabbing was difficult at first, but we utilized the Unity socket for that. Blood flow and electricity animations were difficult because the 1.0 assets weren't usable for us. We had to make everything from scratch for that.
Okay, so for the flashcards, we changed it to be a more modular design so that each flashcard is viewed individually, and Professors can add additional questions as they see fit. After flipping over a flashcard, the student can list the confidence in what their answer was, as well as then select whether or not they were correct, to then submit this to the database so that their responses can be recorded and professors can view and see which students are struggling on what concepts.
All right, this is the cases board. The cases is formatted like a quiz where the answers are ECG graphs and they come in a multiple choice format. The students will be able to get feedback on their answers once they submit an answer. And if you can see on the right side, there's a heart model, and this one beats in the rhythm of the correct answer. So that would serve as an aid for the students. And the struggles we've overcome with this is also making the text readable and recording and sending the data to the database, and also making all the artwork to make this look beautiful. Right? Yeah. And for the technical details, the questions are read from the database by default, but when there's no internet connection, we read those from a CSV file locally. And also we record the time spent on each question and also what the student answered for the question. And these are the login screens. So the student can use those to log in, and they can also log in as a guest if they don't have a username or password.
Now for our database, we decided to host our database on Azure MySQL server, as well as hosting a PHP web service on the Azure service as well to act as an API for interacting with the database. And for our database structure, we decided to go with a simple entity relationship between the students and the material they're engaging with, such as with the flashcards. Every interaction between a student and a flashcard would be stored as an attempt within its own table. Now, some of the struggles we had to overcome were we had to make sure our database would work not just for our group, but for the AR and escape room teams as well as making sure that our database was working correctly within our Unity application.
Once we had our application ready to go, we wanted to actually get feedback from students. So we went down to the Lake Nona campus where the UCF College of Medicine is and tested the prototype on site. We had medical students go through each aspect of the software. So they tested out flashcards, case studies, as well as the actual heart model interactions and heart rhythms. Some problems that we had encountered was the kind of unfamiliarity that students had with VR controls, and that certain aspects that were the default were not preferable to the alternative types of motion.
After getting feedback from student testers, we decided to make several changes. First, we made updates to various different settings in tutorials, particularly with the movement options that are made available to the student. We also added some colliders here and there, fixed several bugs that were discovered, as well as allowed the student the capability to self-report their confidence level with each different flashcard.
Wrapping up our project, a big portion of the success came down to communication. Early deadlines and weekly sprints where we talked about what we wanted to accomplish that week. Bi-weekly sponsor meets with Melissa, talking about what she thought was good, what needed to be changed. Frequent Trello board maintenance, knowing which tasks were assigned to which people. And also Discord communication, talking with each other.
So to start, the user is greeted with the tutorial screen. This will give them the basic controls of the app, as well as how to open up the settings menu and what that settings menu does. We have a login here where the student can use their NID as well as a provided password. M1 room, we have the info board with contractibility preload and afterload. There's also heart interactions here. The user can scale the heart, rotate the heart. They can also grab the heart with the grip button and rotate it in their hands if they want a closer look. Teleport heart will bring it back over here. You could reset that. Swap anatomy will bring up the anatomy labels, which can be clicked for a better view, more detailed view. The heart rate will allow the user to increase the speed of the EKG as well as the heart. There's also tutorial slides for the heart module, as well as other modules will also have the button tutorials available. Here we have flashcards. The user starts it by hitting the next button. If they flip, they'll be able to say whether they're correct and how confident they were, and submit that metric to the database. 2 room, we have more heart interactions. This time you could change the mode of the heart, in addition to the previous controls. Could also increase blood flow, or toggle blood flow, and adjust the rate of the animations, as well as electric flow. Also have more flashcards. This second heart model, which was also an M1. Here we have cases. The user has a question as well as EKG strips, along with a heart corresponding to the EKG strips. They'll choose an answer and then receive feedback for it.
Thank you.